Good day, everybody. We are another chapter down. Chapter 7 has hit the books. We are going to review today for the knowledge we need for the Chapter 7 assessment for the second half, 7.5 to 7.7. I have a 20-question review, and as the norm, we go over all the questions, and if you have anything you want to ask me, we have live sessions on Thursday and the following Tuesday. This assessment for this will be posted tomorrow. That will be on Thursday, May 21st, and it will be due the following Wednesday. Memorial Day weekend is happening this weekend, so we don't have classes Friday or Monday, so enjoy yourselves. The weather will be nice. Let's get outside, okay? All right. Here we go. Question number 1. I'm going to be given these two pieces of information to find the log base 5 of 54. So, what you have to recall are your log rules. How do we break up 54? And we can only use 2s and 3s. So it's 27 times 2. And this is broken down that way. We have a 2 and we have a 3 cubed. That equals 54. And remember, when you multiply, you can add logs. Whoa, if I wrote the right number. Don't forget the base. And when you have a log, remember an exponent can be multiplied to keep the equivalency. So we're going to drop that 3 in front. So now it's just a matter of what is the log base 5 of 2? Well, according to what we were given, it's 4307. 3 times the log base 5 of 3, which is 0.6. Let's try that again. Make it look nicer. 0.6826. So when I put that on the calculator and solve it, I get 2.4785, which corresponds with answer B. Next, we're going to be solving this equation. Now, because the logs are the same and they're being added together, that means by the property we can multiply these two expressions. Now we have a single log on this side. It's the log base 4 of all this. So let's do our conversion. This expression would equal the base of 4 raised to the second power. All right, and it's a difference of squares right here. Just do a little FOIL-ing. We're going to end up with that. Subtract 16 from both sides, or add 9 to both sides if you want. It's up to you. You get m squared equals 25, which means we have two possibilities. It's either a positive 5 or a negative 5. However, be careful. You can never have a negative number in here. If m were negative 5, this would be negative 5 plus 3, which would be negative 2. Cannot happen. So m can only equal 5. Letter B, yet again. All right, for this one, there's going to be a lot of numbers here, so let's just kind of work through it. We have 6 to the 3n equals 43 to the 5n minus 4. Now there's no way we can make these bases the same. Okay, but we can use our log properties. I don't care if you use a natural log or a common log, whichever you prefer. We'll do the common log. We'll do the common log of both sides. When I do that, what does that allow to occur? It lets these exponents now become multiplication problems. Now we have no exponents, so we can solve this like a linear equation. Now, it is a linear equation. It looks funny because log base 6 and log base 43 are just numbers. That's all they are numbers. If you feel more confident in doing it, change them. Do log 6 in your calculator. Make it a decimal. Put that decimal down instead. Okay, it's just a number. Now, in order to solve this for n, and it's probably be the longest problem in the whole review, actually, number 3, who knew, is you've got to isolate the n. So I have a 3n over here, but I have a 5n here, but it's attached to this. So I'm going to have to distribute the log of 43 into these. So it's going to be 5n log of 43 minus 4 log of 43. All right. Next step. What I have to do is get all the n's on one side. So there's an n term, so I'm going to bring it over. So I'm going to subtract that from both sides. And I'm left with this over here. We're almost done, even though it looks like we've taken this nice little thing and expanded it to this monstrosity. But we have to isolate the n. Notice both terms now have an n term. So I can factor that out. I'm left with 3 log of 6 minus 5 log of 43 equals negative 4 log of 43. Now it's at this point, we have one more step to go. I'm going to multiply by this whole big 3 log of 6 minus 5 log 43. Now you notice in this problem, I did not simplify at all. I did not convert these to decimals until the very end, which is why it looks so big and ugly and nasty. All right, so you put all this in your calculator. Believe it or not, you just get this nice little answer here, which is letter A. All right, we got another exponent that is an unknown. So we have to log both sides. Now in this case, I'm going to use the natural log. It doesn't matter. Use either one. And you know why we use either the log or the natural log? Because they're on your calculator and they're easy to figure out using your calculator. Now, anytime you do any kind of a log, what do you do with the exponent? That's right, you drop it in front. All right, good. We got to isolate the x so we can get rid of this natural log of 5. So we're left with 2x plus 1. And here's where I'm going to do this. Right now, I'm just going to put natural log of 50 divided by natural log of 5 in the calculator. You know what I'm going to get? I'm going to get this answer. I do suggest going to 4 decimal places or more. If you know about significant digits, you know in order to get a 4-digit accuracy, you have to use more than 4. But we're not worried about being that accurate. So if you're off by thousands or 100th, you're okay. It all depends on how you round. I'm going to subtract 1 from both sides. So my final answer will be, I'm going to take this and divide everything by 2. If I divide it by 2, I get 0.7153, which you'll see is right here. Okay? Well done. Let's keep going on a roll now. Common logarithms. All right, that's log base 10. So remember that little formula that we had. In order to figure this out, we can do log of 207 divided by the log of 9, and that's it. Throw it in the calculator, and when you throw it in your calculator, you get the answer of 2.4270. All right. There are going to be some word problems. Some of you might be wondering, hey, there's section 7-8 we didn't do. Why did we skip 7-8? Well, 7-8 we've done all along. 7-8 is just story problems based on logarithms, and we've been doing them the entire chapter. And this is the big one that we came up with. And we're going to use that to figure out this equation. And then from the equation, we're going to figure out how much money you're going to have. So the P is your starting value. We started with $1,000 in this account. It's a 3% annual interest. And as a decimal, that's 0.03. And it's 10 years. So guess what? There's our entire expression. All we got to do is find that answer. Put it in your calculator. And when you put that in your calculator, you get this. That's how much money you're going to have after 10 years. Say you made $300 for doing nothing. It's not bad. Not bad. All right, solve an equation. Now, again, the unknown is the exponent. So we're going to have to do a log of some kind here. But before that, let's just get that e all by itself. I'm trying to isolate this variable. It's 27 minus 4 is 23. Divide both sides by 3. All right, here's what I end up getting. Now, the easiest thing to do here, since we're using an e, remember what the inverse of e is? It is the natural log. So if I take the natural log of both sides, something wonderful happens. Natural log of e equals 1. The 5x comes in front. That's the equation that we end up getting. So I did this. I converted that to a decimal. It happened to equal 2.0369. Divide both sides by 5. And you get 0.4074, which is letter A. Now we have this equation. And we're looking for something called a half-life. Remember what a half-life means. A half-life is, say you start with 100. Then it's going to go down to 50. It's going to be half as big. So we're not given how big it actually started, but we know it's going to be half as big. Is what we're looking for. So let's just, for the sake of argument, let's just say that there was 100 to start with, and it went down to 50. So using this formula, 50 is where we're at right now. The A is where we started. We know we got 0.0974, and we don't know t. We're actually solving this equation. So if I divide both sides by 100, I get a half. Now you might be thinking, wait a minute, how can you say, how do we start with 100? We don't know. You just can't make that number up. You're right, I technically can't, nor should I. However, whatever I started with here, once I divide both sides by 100, it's going to be half. This means there's half left, and that's what we're really concerned about. All right. Now my unknown is an exponent, so how do I get rid of it? Well, I got an e, so the easiest thing to do is natural log. All right, the natural log of 1/2 is negative 0.6931. And this e and natural log are inverses. They kind of cancel each other out. You're left with 0.0974t. So how do you solve for t? You just divide both sides by negative 0.974. Negative 0.974. T is about 7.1165. So it's going to take about 7.1 days for that compound to lose half of its mass. So to me, that's pretty radioactive. It only took a week to shrink by half. All right, another formula we talked about. Now these formulas, there's 3 of them. There's actually 2 of them. Because the one we just did has different ways of writing it, but it's always the same formula. This one is just if we're doing annual change, instead of a continuous change. But either way, you don't have to have these memorized. I'll give you the formulas that you need to use. The starting value of this hotel room was $48 in 1990. It went up by a rate of 5.1%. Well, 5.1% as a decimal is 0.51. Now I've got to raise it to the t power. Now how long was it? Well, how long is it from 1990 to 2022? Well, from 1990 to 2010 years, 10 plus 22, so it's 32 years later. Now if you assume that it went up 5.1% every year for 32 years, guess what the hotel cost is right now? $235.79. Now that seems like a lot of change for only 32 years. Imagine if that keeps going and keeps going. Pretty soon nobody's going to be able to afford these hotel rooms. But that's the mathematics for you.